There's scalar multiplication, there's something called the dot product, and there's something called the cross product. Okay, we are going to talk about scalar multiplication, we're going to talk about dot product in here. Cal 3, you go to the third one, which is called cross product. The reason we don't do that here is because you have to do you have to have three-dimensional vectors to talk about cross products. So first type of multiplication, scalar multiplication. Scalar multiplication of vectors. So let's say you're given some vector v, all right? Let's say you're given some vector v, and then you want to find what c times that vector v would be, where c is a number. So I'm going to show you an example right now, okay? If you look at the TV screen over there, what you're going to see, hold on, let me see here. All right, we have a vector v here, okay, which is this, it's hard to see, it's the black vector which is under the red vector. What I'm going to do is I'm going to start multiplying that vector v by different numbers. So let me multiply it by 2 first. Right up here in the top right, this red vector is twice v. What did it do? What does it look like? It doubled its length. If I do 3 times v, it tripled its length. Do you all see that? What do you think multiplying it by a negative number does? Don't we already kind of know? What happens if you multiply a vector by -1? What does it do? Makes it go the opposite way. So watch, there's -1 right there. There's negative v. Do you all see that? There's v to the right, like this. Negative v is pointing in the opposite direction, same length. If I do -2 in front, I think I went too far. -2. There's -2. So it's twice the length of v, but pointed in the opposite direction, right? What if I did like 1/2 in front of v? What do you think it's going to do? Trim it, yeah, make it shorter, right? Make it, scale it, it's going to be half as long. Okay? It's going to be half as long. So how do I say this? How do I actually summarize that? Where the heck is this? How do I summarize this? Well, right there, all right? It says, given a vector v and a scalar c, a number, then c times v changes the shape of v. If the absolute value of c, so if you take the absolute value of that number, if it's bigger than 1, it's going to stretch it. Stretch it, right? It's going to make it longer. If the absolute value of c is less than 1, like a fraction, like 1/2, it's going to shrink it. Okay? And if c is negative, it's going to flip it, right? It's going to change the direction. Yes?
When we say like stretch and shrink, we're referring to v, correct?
To the original, yeah, it's going to stretch v, or it's going to shrink v. And it goes exactly the way you would think. If it's a 2 in front, it's going to double the length. If it's a 3, it's going to triple the length. If it's 4, it's going to quadruple it, right? All right, let's see if we can put this all together, all right? I'm going to draw you some vectors. Let's let this vector be the vector u. Let's let this vector here be the vector v. Okay? I would like for us to find negative 3u minus 5v. I want us to draw that vector. Negative 3u minus 5v. So let's start by trying to draw these things out. What about this? What can you tell me about that vector? It's negative, which means I've got to flip a vector over. What vector am I flipping over? U. So it's going to flip this vector over, right? Because it's negative. Okay, now the number itself in front is a 3, right? So it's going to make it 3 times longer. So it's 3 times longer, but it's pointing in the opposite direction. So imagine taking this vector, flipping it over, and making it 3 times as long. So like here would be, that's the opposite direction, right? That's 1 times as long, 2 times as long, maybe like 3 times as long. That vector right there. Do y'all see that that's u flipped over in 3 of them? This right here would be the vector negative 3u. Got it? All right, and then I've got to figure out what this is, right? So I would do this if I were you. I would rewrite this like this, change that to plus, and make that negative 5v like that. That way you can go tail to tip, tip to tail, but you've got to figure out what negative 5v is, right? So what am I going to do to figure out what negative 5v is? Well, negative means what? Flip over, right? Opposite direction of v, right? So it's going to be that v, but opposite direction means straight up, right? And then 5? 5 times as long. So I need to take this vector, flip it over, which will point it up, and make it 5 times longer. And I think that's going to get in my way over here. So let me just do it here. If this was, I can slide that around, right? It's a vector. I can move it wherever I want. So I'm going to put it here just to make it easier to reference. So there's v. Negative v will point up. This right here, that would be negative v, wouldn't it? That'd be negative v. But I need 5 of them. So 1, 2, 3, 4, 5, right? That entire vector right there, this big vector like this, that would be negative 5v. And I want to add those two together, right? So I start with this one. Let me just move this over here like this. Okay. Right there. That is negative 3u, right? That's negative 3u right there. And then I'm going to take this vector here. There, right? That vector from here to here, roughly, that's negative 5v. And so the answer is what you get when you start here and end there. That is the vector negative 3u minus 5v. Getting a little bit lazy with that. Still good or not? All right, a definition. What does it mean for two vectors to be parallel? So this is a definition. This is kind of a strange definition. Any two non-zero vectors are said to be parallel if they are scalar multiples of one another. What does it mean to be a scalar multiple of one another? So two vectors are said to be parallel, right, if they're scalar multiples. So I'm going to see if you can understand this visually first. Let's say I give you this vector, I call that vector v. Okay? My question to you is this vector, I'm going to call that w, are those two vectors parallel? What do you think? Don't think so? Yes? No? Yes, no? So if you think no, can you explain why you don't think it's parallel?
Well, they're not in the same direction.
They're not in the same direction? Okay, and they're not the same length. So I would agree that these two vectors are not equivalent. These are not the same vectors, right? But are they parallel? To be parallel, all they have to be are scalar multiples. Now, they're not pointed in the same direction, but do you agree that w is just this vector flipped over, which means we're multiplying by a negative number, and then we're making it shorter, which means we multiply by a number that's less than 1. So we can get from v to w by multiplying v by a negative fraction, and then it would become this, right? So there's some number I can multiply in front of v that would get me w. I don't know what the number is, but I know that this number would be negative and it would be a fraction. And then I would get w somehow, right? And so you see that this is what it means to be a scalar multiple. This vector and this vector, I'm not saying that they're the same. I'm saying there's a number I can multiply this by to get that one. So to be parallel vectors, you can imagine that, I guess an easy way to think about it is if these were lines, if they were lines, right? They're not, but if they were, would they be parallel? Yeah, right? That's what makes two vectors parallel. All right, almost ready for that, not quite. So hanging in there, still got 20 minutes. We get Thursday off, so.
We should just start the day off.
Yeah, we should. We're here though, right? Bonus points on final for what? For coming on Thursday? Oh. No, thank you. No, thank you. Let's see here. Okay. If v is equal to the vector -3, 4, and w is the vector, let's say, 5, -7, I want us to find -3v minus 4w. All right, this is a problem that is similar to one I did a second ago, right? I gave you two vectors and I asked you to find something like this just a minute ago, right? But I drew you the vectors, didn't I? I drew the vectors and you had to like flip and stretch them out and do all that. Here, I'm giving you the vectors algebraically in their component form. And I want you to find this using that, right? So to do this, I don't have to draw any pictures at all. All I have to do is replace v and w with what they are. So I'm going to rewrite this. This is going to become equals 3. Okay, and then I write the vector v. Watch the way I write it. Angle bracket 3, 4. And then minus, then I do 4, and then I do angle bracket, and now I do the w vector. Okay, do you all see that that's -3 times v minus 4 times w? Right?
Is that how it's supposed to be written, or do you want us
Yep.
to put the vectors in parentheses?
No, the vectors don't go in parentheses. They stay like this. Now, when you do multiplication, scalar multiplication of a vector, we realize that's like stretching and flipping and all that. But when you do it algebraically, you do what you wish you would do here. You just distribute this through the vector. So you just go -3 times -3 is 9. And then you go -3 times times positive 4 is -12. See how I distributed that? This through. And then over here we do the same thing. But my question to you is, do you want me to keep the negative and distribute the 4? Or do you want me to distribute a -4 through? It's totally up to you. You want the -4 through? Okay, if I do a -4 through, I have to leave a plus sign here. You were really looking at this as being like plus -4 and then distributing the -4 through. So we still have a plus here. Now when the -4 goes through, we get -20 and then we get positive 28. Okay? And now, how do you add two vectors together? I showed you this earlier. How do you add two? Don't tell me tail to tip. That's geometric. That's visually. Algebraically, how do you add these? Yeah, you just add the components, right? You just add the components together. So I'm going to take this 9, and I'm going to add the -20, which gives me -11. And then I'm going to take the -12, and I'm going to add the 28, which gives me 16. That's the result. All right, I'll make this the last thing we do, maybe, I think. So finally, the magnitude or the length of a vector. We've already said that other than the 0 vector, all other vectors have some length to them, right? The 0 vector is weird. We can say it's 0. We can say the length is 0, but every other vector should have some non-zero length to it, right? So first of all, how do I tell you I want you to give me the length of a vector? What's the notation I use? And then the other thing is, how do we do it, all right? So we put an absolute value around the v. All right, if we do that, then that means find the length of the vector. Now, some books will do a double absolute value like this. Just so you know, like maybe in like a physics class or something like that, they might do this to represent the length of a vector. In the calculus book that we use here, this is the way we represent it, all right, which is pretty normal as well. So both of those are commonly used. This right here means the length of the vector. And the definition of this is very simple. It's the square root of v1 squared plus v2 squared. I should note here, if you have a vector, we're talking about some vector v, it has the components v1, v2. Okay, so if that's given to you, some vector v1, v2, if we want the length, this is the way we denote it. We do the absolute value of it, and all it is that computation. Now, to see why it's that is pretty simple. If I take a vector, v1, v2, right? There's my vector, v1, v2. If I can move that vector anywhere I want, right? Anywhere I want. So if I slide it around and I put it at the origin, just like that, if that's like the x and y axis, if I do that, then you could draw a right triangle. And then the distance from here to here would be v1. Distance from here to here would be v2. And then the distance we want right here, that's the magnitude of the vector. That's how long it is. We could say this squared plus this squared is that squared, right? So you could say v1 squared plus v2 squared equals the magnitude of the vector squared. And then to find this, you take the square root on both sides. Does it make sense where that formula would come from then? It's just Pythagorean. All right, So let's do a quick example of this. If V equals -1, 3, and W equals -2, 5, here's what I'd like for us to do here. First thing, find the magnitude of V, or the length of V. That's the first thing I want us to do. The second thing I want us to do is I want us to find 2 times V minus 3 times W. And I want to know how long that vector is. See what I'm asking you to do? And then finally, I want us to find what 1 over the magnitude of V is times the vector V. Now that looks weird. I'll explain it when we get to it. That's it. This will be our last 3 problems, and we're going to call it a day. All right? As far as homework for this section, I'm going to send you all something. All right? I've removed the online homework. I've taken it off. And I want to put together my own assignment for it, and then I'm going to send that out to you. All right? Look for it probably after Thanksgiving. What else? Oh, I also have a review for the final that I think I'm going to send out. It's a bunch of old finals and old reviews. It's like 17 pages long. I just threw like a bunch of stuff into one big file. So I'll send it all out to you. I'll send that to you all probably over the weekend as well. All right? It's just something for you to look at for fun. All right, let's do this. Let's do part A first. All right, part A. So for part A, let me see if I can squeeze this in over here. I did. Played lottery today. All right, so for the magnitude of V, what I need to do is the square root of V1 squared plus V2 squared, right? That's the formula. Which for us, do we know V1 and V2? Do we know the 2 components of this vector? We do, don't we? That's V1 and that's V2. So I'm just going to take each one of those and square them. So -1 squared. I add to that 3 and squared. This will be square root of 1 plus 9. That's the square root of 10. And that's my answer. That's how long that vector is. I did that on purpose. All right, got it? That's how long that vector is? All right, how about part B? How are we going to do that? Ideas? Yeah, like figure out what that is first, right? Like that's a vector. Let's figure out what that vector is first. Once we figure out what that vector is, then we'll go do the formula for the magnitude, all right? So I've got to first resolve that. Jesus. Okay. So I'm gonna need this right here. Let me take this space. So for part B, I need to know what first 2V plus -3W is, right? Or you know what? Let's do it this way. 2V minus 3W is 2 times the vector V, which is -1, 3, minus 3 times the vector W, which is -2, 5. So all I've done there is replaced V with what V is over there, and I replaced W with what W is there. Now distribute, right? Distribute the 2 through. Distribute, we'll do a -3 again like we did on the last one. We'll leave a plus between them. -2, 6 plus, what's the second vector here? 6, negative 15. Now add those two vectors. What do you get?
4, negative 9.
4, negative 9. There we go. Y'all good with that? That's what 2v minus 3w is, right? It's that vector. Now we haven't answered part B, right? Part B wants the magnitude of that vector. So what I'm going to do now is say that the magnitude of 2v minus 3w, the magnitude of that will be the square root of, now I'm just going to take each of these components and square them, right, and add them. So I'm going to put in here 4 squared, I don't need this like that, plus now negative 9 squared, which is the square root of 16 plus 81, which is square root of 97. Pardon?
Is that still part B?
Yep, so for part B, I needed to find the magnitude of this vector, right? The magnitude of this vector. So the first thing I did is I just found what the vector is first. Once I found the vector, then I used the formula to find the magnitude of any vector, which is that right there. Clear? All right, next part, can I move on to C? Okay, for part C, what I asked you was to figure out what 1 over the magnitude of V is times V, right? But wait a minute, didn't we find out the magnitude of V earlier? What was the magnitude of V? We did that on part A. Square root of 10. So isn't this 1 over the square root of 10 times the vector V?
Yep.
Yes? Do you all agree that 1 over root 10 is just a number? Right? It's just a number. And I'm multiplying that number times my vector. So I'm going to write it like this. 1 over root 10 times the vector V, which is negative 1, 3, right? That's what that means? But multiplying by a number, I do what I did here, right? Just distribute the number through. So when I distribute this to here, I get a vector, negative 1 over root 10. And then when I distribute here to here, I get 3 over root 10. And that's the result. Yes? You got it?
Yeah.
Sure.
I was going to ask why you didn't use -2 by root.
Oh, yeah, because I wanted to know 1 over magnitude of V times V. All right. Almost done. Almost done. There's something about this I want you all to see. You see this right here? When you take what I did here, let's just talk about what I did. I took the magnitude of the vector. I did 1 over the magnitude of the vector, right? And I multiply it times the vector itself. Right? That's what I did. I would like for us to look real quick at what the length of that is. Okay, so this thing that we just got right now, how long is that vector? How long is it? I didn't ask you this. Let's make this part D. Find the magnitude of that vector we just found. Well, you would do the square root of that squared plus that squared, right? So negative 1 over root 10 squared plus 3 over root 10 squared. And what you get here is square root of, what is this? When I square the top and bottom, what do I get? Square the top? 1 over 10. Good. Plus, when you square the top and bottom here, square the top, you get 9. Square the bottom, you get 10, right? What's 1 over 10 plus 9 over 10? 10 over 10? What's 10 over 10? 1. Square root of 1 is 1. So how long is this vector? 1. Okay? That's how long that vector is. We're going to cover this next time we meet. It turns out that if I give you any vector, okay? So let's say we start with the vector. Let's say I start with the vector like this. I call that vector v. Doesn't matter where it is. Okay? If I start with that vector, and then I take this vector, 1 over the magnitude of v times that vector, that creates a new vector. This vector points in the same direction as this vector. But it has the very, very nice property that the length of it is 1. So anytime someone gives you any vector, you can always calculate this. It will generate a vector that points in the same direction, but only has a length of 1. And we call vectors that have length of 1, we call them unit vectors. And those turn out to be very important. That's probably beyond what we'll talk about in this class. Do any of y'all have to take linear algebra? No? Maybe not? Okay. Then you take that class after you take Cal 2. Computer science majors? No? Yeah, linear algebra, yeah. Yeah. So, all right. Well, look, let's call it a day. I will send out assignments. I'll send out the review. Everybody have a great holiday. I will see you again on Tuesday. We have 2 more class meetings, right? We're doing more vectors. I'm going to do vectors to the very end. We will review a little bit for the test, but I'm not going to spend a whole day on review. If you want to review, you form study groups, you come to my office hours. I'd be happy to help you out to get ready for the final. All right? All right, y'all take care.
I forgot to submit the homework for last class. Can't remember what was the number.
For law of cosines and sines? Or no? Let me turn this off. Are you not the last 2 assignments we had in here was law of cosines and law of sines.